a bit of black pastel, a little bit of albino, cesium 138, and for a pinch of my secret DNA. Yes! Yes! The ultimate ball python!
Whoa, what's going on in here?
Oh, just making the ultimate ball python.
Ultimate ball python. Doc, that's not how we do it. Maybe in the future your crazy science will do that, but right now that's not how we do it.
Science!
The people aren't going to understand that.
Audience?
The audience. The ones that are watching you right now on YouTube.
What? Oh. Hi, everybody. Didn't see you there.
You didn't know you were on YouTube? Well, you're on YouTube. How about we put all this craziness away and we just sit down and we talk some basic ball python genetics, terminology, all that good stuff. Just something that everybody can have a base idea for. And then, I don't know, maybe in the future we'll get back to your science, okay?
Okay, let's do that.
All right. Okay, everybody, let's get started. Hey everybody, welcome out to another episode of Balled Up Genetics. My name is Lloyd, and if you like reptiles, then this channel's for you. If you can first do me a favor by subscribing down to the channel if you haven't already. Turn on those post notification bells so every time we upload a video, you'll be informed. And of course, if you can share these videos, it'll help our channel grow even more. Don't forget to check us out on Morphmarket and also on Instagram. All right, just like I mentioned before, today's episode, we're just going to go over some quick, basic genetic terminology for everybody who's starting out. This is stuff you're going to hear when you watch other YouTube channels, reptile channels. When you go to reptile trade shows, you're going to hear some of this terminology thrown around, and it's going to give you an idea of, you know, a basis for what everybody's talking about. Because believe me, genetics, when you start talking about genes and DNA and alleles and phenotypes,
DNA and science!
Calm down, Professor. Calm down. We're not going to get that deep into it, okay? It can become very dry and boring.
Science is not boring.
Yeah, it can, Professor. And we're not going to get that deep into it, okay? Sorry. So just some basic things. We're going to quickly go over DNA. We're going to go over to genes. We're going to go over dominant, codominant.
That's incomplete dominance.
Yes, Professor, I know technically it's incomplete dominant, but for this video it's going to be codominant and then recessive. And then also in the recessive category, we're going to touch upon what you'll hear them say het, 100% het, 50% het. It's heterozygous for recessive. And we'll get to that in a minute. So, you know, DNA is what makes us. We get half of DNA from one parent, half from the other, and then that's us. In that DNA information, there are segments called genes. And those genes give us certain traits. So like eye color, skin color, hair color. So in ball python world or snake world or the reptile world in general, it has to primarily do with pattern and color. And that's the gene. In the reptile world, we refer to it more as morph. Hey, what kind of morph is that? Is that a albino? Is that a pastel? Is that a clown? That's the morph that we're talking about. Okay, so the first category we're going to talk about is dominant gene. A dominant gene is one that can reproduce itself without the other parent having the gene. So for instance, like this pinstripe. I can breed this pinstripe to a, let's say, a normal wild type ball python, and half of its offspring are going to look exactly like this snake. So this snake can reproduce itself with another snake with only it carrying the gene. They don't make a super form of themselves. Typically, a super form is dramatically different looking visually than the original parent. Also makes major changes in pattern. Pinstripe will make major changes in other snake pattern. Leopards, a gene called leopard, will do that. We'll change that pattern dramatically, enhance it when bred to another snake. So that's a dominant. But again, just remember, a dominant gene snake, one, doesn't make a visual super form of itself. Two, it can reproduce itself, its gene, when paired with another snake, and that other snake doesn't have to have that gene also. So it can reproduce itself without the other parent carrying the gene. And a lot of times they will make dramatic pattern differences in those offspring. So that's what a dominant gene will do. So now let's go ahead and move on to the codominant. The next category is codominant. So codominant acts like a dominant, but it has something special with it too. It will carry its genes over to an offspring. So for instance, if I bred this Mojave with a normal, I'm going to get some of the offspring that will look like this Mojave. But also, it can make a super form, codominant to a codominant. You will get a visually different looking offspring. So, and in this case with the Mojaves, you'll get a white snake with blue eyes. So they're called a blue-eye Lucy. So again, in a dominant, you won't have that happen. That dominant gene, the offspring will all look like that dominant gene. In a codominant, they will throw out what's called a super form, a visually different looking snake than the adult pairs. So now it's time to talk about recessives. A recessive is a snake or a reptile that is where both parents need to be carrying that gene in order to produce a visual looking animal. If only one parent is carrying the gene and the other one is not, then they will not produce a visual looking. So for example, albino. In order to get a visual albino, both the mom and the dad have to be carrying the gene for albino. If I were to breed this albino to another snake that doesn't carry that gene for albino, I'm going to get all the offspring looking like that other snake or looking like a normal. So for instance, if I were to breed this albino to this normal, all the offspring will come out looking like her because she does not carry the gene for albino. Now all those babies will be carrying the gene, even though they look like the mom, they will be carrying the gene for albino because he was a visual looking albino snake. So that's where we get into heterozygous or het. So all those babies will be a 100% het for albino because the dad was a visual looking snake. Even though the mom didn't carry the gene is in the babies, so then they are hets. So sometimes you will buy a snake that looks normal. For instance, I have one right now this year we're trying to prove out it's het for albino and it's het for pied. But it looks normal like this one. But it's carrying the genes for albino and the genes for pied. And I have to breed it to either a visual albino or a visual pied to see if it's carrying that gene or not through its offspring when it has its offspring. Okay guys, so that was it for this video. I hope everybody kind of got a concept of the terminology that we use in the industry. Is very, very basic, but I hopefully made it kind of simple for you guys. If you ever want to get more in depth with genetics, let me know in the comments down below. And I mean, yes, let's talk DNA. a science, we can make a really good video on genetics, but I don't know. I don't know how boring or entertaining it might be, but we can give it a shot. But I was hoping in this one, just going over all this stuff so you have a base idea of what's going on. I hope everybody's enjoyed this video. Don't forget to like if you like it. If you don't, give it a thumbs down. At least share it with people. So the more these videos get out, the more this channel is going to grow. Maybe you'll see the professor more often.
All right. Maybe next time.
Again, I also want to give a shout out to Sea Turtles Inc. down in South Padre. With the extreme cold that came through this state, it really messed up the sea turtles along the coast. The last time I looked into it, there were over 7,000 strandings of sea turtles. A lot of them didn't make it because of the cold. But if you guys can go on to their website and check them out, help out in any way as possible, they would greatly appreciate it. So that's it for this video. Until next time, take care, and we'll see you again. My name is Lloyd, and if you like reptiles and not coughing, Doc, what are you doing? Mess up the door. Let me do that again. Take 3.
Next time we will talk DNA.
Oh, sorry. Man, it's hot in here.